I don't know what happened to the camera settings. It's so weird. It's very noisy. The camera setting is very noisy. So I had to change that is like, what happened to the f.4? Okay, yeah, we have this setting. Okay, f2.8, way better, I believe. It's so weird. Okay, I hope. Oh yeah, there is also this stupid ISO auto. Okay. I have to change everything because somehow okay, off. Yeah, the processing. All right. So I'm late today because I checked. I knew that my certificates on my website are running out at some day these days, and I checked, and they were expiring in 20 minutes. So to use the chat with Chrome, the TTS chat, we had like I had to refresh the certificates. Yeah, there should be all right. Yeah, Certbot. I have Cert. Certbot doesn't work automatically for wildcard certificates since you need like to add an entry in the DNS settings. Somehow the focus is still weird. Let me change the lights. Maybe that helps. Oh, you have? Really? Where are you? What is your DNS provider? Sonic, maybe we should. Okay, I'm at Hetzner. I don't know if there is a way. I have still like the STM fan t-shirt from yesterday on, so I'm very filthy. Hello, Brian. So let's greet the people. TMK, hello. Sonic, ITT. I hope you got better. Haven't you been sick last week, or no? You are just tired. Hey Jordi. Hey the Shipu. Hey Max. Brian, Kasper. Yeah, that's about it. And the lurkers. Hello to lurkers. I just noticed how greasy my hair is. I'm sitting here. I'm like a super nerd because I'm sitting here and coding, living on the edge. So I'm super nerdy, mega nerd, and coding and renovating and doing all that stuff. So, and I want to fun. No, I hope no dig. Do you wear high socks? No, I have like comfy socks today because we had yesterday night. So today night it was okay. It was about 17 degrees maybe, or 15 degrees, or it was like 2 digits at least. And no sandals. Let me zoom back a little. Here we go. And we had, during the night, it was below 10 degrees C 2 days ago. So it was quite cold and it just started to warm up. So I was just sitting at home and fixing things. So what changes do you want to see? Do you want to see like the current hope winter is coming, and I hope my heat pump is coming as well. And I might have underdimensioned it because I bought a 9 kilowatt heat pump, but apparently at minus 12, what would be like minus 14 is like the lowest temperature that get here. It's only able to provide like 5 kilowatts. So I'm not sure if that's sufficient to heat the house. At least maybe like we will cuddle in one room and eat that with that. Apparently, that means I have like to speed up my renovations and improvements regarding the insulation. Minus 17 degrees. What? Yeah, then I would have like to. I mean, we still have regular convection heaters, so they have a COP value of 1. And also, my ultra cluster, I need to finish that. The final one will have a heating power of 3 kilowatts, so that's something, or 2.4. I don't know. So it's it will be potent enough to heat 2.6. What? 2.4. What? Oh, yeah. What? 14? 2.6. Oh, yeah. I bought a Polish brand actually. Fox Air 9 kilowatt hours. You can Green Line. They have COP of around 5 if you run them like at 35 degrees or something. Yes, I hope to, but I'm not sure if I will be if I I need to watch a few tutorials still. Yeah, I'm not sure if that will work. Especially because okay, I only need one phase power for that one. I hope it works. Yeah. Oh, yeah, I have the a limit of 41 degrees C more or less. I think 42 is maximum for HVAC guy. Okay, I don't know that one. Um, because of the parquet floor, like the wood floor in the living room that we will put in there, has a limit, surface limit of like 41 or 42 degrees C, which otherwise it will dry out. So the highest temperature that I can run the heating at is like 45 maybe. It will be a curse of software and maybe a little bit fall off temperature. Yes, I don't know what's the English term for that. Anyways, I calculated around, and apparently I have only like a floor heating in the living room yet. So the plan is to put it everywhere, but it took me a year to finish the living room. So, oh, yeah, I will just put regular heating elements in the other rooms, the cheap ones, two-layered ones, um, because they're like a type 33 is like they're very thick and they're more expensive and heavy, but if I want to run them at this low temperature, I need active convection. So they are basically equipped with fans that are regulated with some controller and basically improve like the airflow. And these are built only like type 22 heat exchangers. Well, let me show you that. Uh, I'm not depressed at all. From Lowe's, yeah, I have no styrodur. Yeah, I have like living room is insulated. I mean the walls are mediocre insulated, but there is at least some insulation. The other rooms are not. This room can be insulated, but I need like to tear down this wall, this wall, and basically replace it because that's like the roof, but it's only brick. Uh, the advice: go for a walk, sleep well, and go for a walk. Do something else for a change. Work out, yeah. Go hiking and seeing, like climb a mountain. That's my advice. Okay. Hot tea, Kasper. Okay, so this is type 11, no good. Type 22, that's the one. Type 33, we could use, but then you have only the fan is installed here. So I will get cheap as type 22 heating elements and will just add fans. Um, you can get like we can use PC fans and basically build it, or we buy that extension like finished. Jordi showed me like Action has some super cheap ones and he used them before and they are right. So I will just make heating thing, like active convection heater, where that usually costs like $350 for around about 120. And the only thing that worries me right now is the piping, and I need like some vents. I will use most probably like so this flexible type, the type of pipes. How's it called? Verbundrohr. I don't know how it's multi-layer. Yeah, clamping device. I need that. Yeah, Action for the win. Um, yeah, so yeah, crimping device. I will probably. I don't know. I might invest in that because I will do more piping. The piping will stay for the floor heating as well. So I will just replace the heating elements later, one by one, when I'm renovating the remainder of the house. Anyways, I hope it will work out. If it won't work out, I will heat with the convection heaters, the regular ones, with a COP of 1 and with my ultra cluster. And there will be no difference to the years before, where we spent like thousands of euros for power heating and whatever. But I hope I mean, last year we had like still around, I think even Christmas was 10 degrees or something. So it wasn't very cold, but the January, February, and then so on, I think it was cold quite long, but not super cold. There were only like, I think a total of 2 weeks where it was okay. We have below zero. We had maybe 2 months, but never like minus 10. Minus 10 was maybe an exception. So I hope it will work out. Otherwise, I will just add some insulation. Johnny, look at this. I'm wearing still the same shirt as yesterday. It's still valid. It's only 25 hours now that I'm wearing it. Anyways, let's not get distracted with that stuff. Oh yeah, you want to see the heating, the heat pump that I Fox Air 9 kilowatt hours. This is it. They certificate their certificate expired. So actually this is shipped from Poland as well. So it's now being shipped, and yeah. Oh no, Johnny. You need to wait now. Maybe. So I got it cheaper, and it's I think it's shipped from Gliwice in Poland, which is cool. It's also a Polish brand, and it's a monoblock. So everything is contained within the device. It's only 80 kilograms heavy, so I will just make a simple foundation for that outside, and I even have a place where I can attach, like, because that's defrosting, you have like defrosting cycles, so it will drip some water, so I can even collect the water and put it to a drain, like rain pipe, so that will be drained, no problems there. And I just have to drill through the wall. I need to add a vent, like the overpressure vent or something. I don't know. There are a few things that I need like to do on the other side, and then I will add a manifold basically for the pipes that are going everywhere. Efficiency wise, it looks cool. I saw some some reviews online, like German forums. The only complaints, like I think from last year or 2 years ago, where this was introduced or whatever, it was you don't. You never you never touch the coolant. The coolant, everything is contained. You only attach the power and the water pipes. So, and the controller. There's like people were only complaining. Oh, there's only I don't know. The water pipe certainly not. Quick connect would be maybe for the coolant or whatever. But this is let me check here. Yeah. So people were only complaining that the firmware or the menu system is in Polish, but I have no problems with that. And also they found like a firmware or got a firmware from the manufacturer in English. Refrigerant, I think Sonic mentioned it's propane. Here is the power, so you can see it only provides, like, if I run at 41 degrees C or 45, only 5 kilowatts, which is not that much, especially if it's that cold, like -12. Yeah, I think it's mentioned here somewhere. Yeah, R290. Okay, and 1.5 kilowatts for 12. Yeah, that's probably what I should have taken, because we have like 80 square meters, which should be not enough, unless COP, also look at that, not great, 2.5 at these temperatures, like minus, yeah, around about minus the lowest norm temperature, and here will be that. But I assume most of the time I'll be running at 3.5 COP, and then who runs it at this? Or 35, it's if it's 35 degrees outside, it can do a COP of 7.88 from 35 to 35. Huh? Oh, weird. Yeah, it's still 7 to 41, whatever. So currently, if we have like 10 degrees C outside during the night, would be COP of 4. Anyways, if it's not enough, I mean, that was like 1.5K. If it's not sufficient, I would just buy a second one and attach it again. Like, I have no... oh, yeah, I need a Druckausgleichsbehälter. Okay, maybe I need that. That is another thing. But I would just buy a second one. It's still cheaper than buying like one for 5K or something. And then I can even run a split like one stereo. Yeah, there are modes which it can switch. Basically, also if you want to heat water, it can switch to a higher temperature automatically to make warm water. But if I would use two in the end, yeah, you can cool with that. That's actually really good, because we had I wasn't able to work here during the hot days, like 30 degrees. My brain stops working. A bit problematic because you get condensation everywhere. So if you use that, it might cause like mold or whatever if it condensates water. But I don't think if you like lower your temperature constantly or keep it at a certain level, there shouldn't be a problem with that. Yeah, especially if you don't have like a huge difference. So your brain stopped. Yeah, 26. More or less. I mean, I noticed that 30 was basically unbearable. Anyways, that was that excursion. I changed a little bit of code to improve things. So I don't know what your last state is. Maybe I will switch it on, the thing, and run it. Where is it? Here. Okay. All right. So this now has no losses, so no packet losses, no nothing, and it runs basically at the limit of what the USB is giving us. Yeah, traditional. This is I could calculate. We have, what is it? The problem is that basically the USB is limited. The driver, CDC driver, only limits to 255 bytes per packet, which is stupid. We were using 260 for combined full set of 32 messages that we would route to level 1 and then distribute to the individual MCUs. But I implemented compressed just RGB values, which are 96 bytes, 32 times 3 bytes. It's 96 bytes, and basically level 4 receives that packet, USB packet, and then constructs an actual message packet that it forwards. That works well because then I just send 100 byte packets. And we can calculate basically, so what is it? So 1000 divided by was 27 is the average. So we have 37.3 times 100 bytes times 16 times 16 again. 16, yeah, basically 1 megabyte per second. So it's 8 megabit. This is what we get, like with 8 megabit is max what we can get out of the CDC here. It's a little bit unfortunate, but let's work with that. We are not limited. I have removed all the delays from the code as well. So if you look at yeah, no packet losses because okay, so if unfortunately I unhooked maybe I can still hook it up again so you can see that the two probes here. The SPI is so dense we can basically increased also the clock speed, the base clock of the L4, and I increased the clock speed of L2. It was divider or prescale was 16, and I'm using oh, it stopped because I have not the website open. Where is it? Here we go. Okay, so let me show you that. So if I pause here, okay, this is how dense it looks. Does it focus? Here, focus. Okay, this is the chip select of one individual blade. So actually in between we have 16 packets of, and there is like no breathing air anymore. The SPI is full speed. Yeah, the SPI is full speed, and I improved things. So this is that. I'm switching to a testing environment now. So the task for today will be to develop the firmware of the little 40 frames per second. The task is to develop the firmware that will be able to upload and download data from and to memory and run code from there. So very ambitious plans, but I wanted to show you also the differences now. Let me check the code can share what we did there. Okay, let me move the window to the other screen. Okay, so code. Whoop. Basically, fill message. Yeah, that's the new functionality. Let me add, yeah, here bigger resolution. It now has like different packet styles. So either, yeah, that it will be ignored because we don't support like individual messages anymore. This was the old style. This is the new style. It basically takes the RGB values that are here. Wait, no, this is the address of L1, and this constructs basically the address of the L0s based on the L1 address, because they are the children, all the children from 0 to 31. And here are the RGB values, and yeah, the 67, which was our signature data for that RGB packet. So we are actually communicating full packets over SPI, and yeah, this runs, let me check, the prescaler is still 4, so we could actually double the speed maybe, but I don't want to. I increased the clock speed from 72 times 2 because I'm using a different, so this was 144, and this is actually running now at almost 200 megahertz. So it's 192 megahertz. It's overclocked, but it seems to be working fine. It will probably, I don't think it will struggle if I lower the clock speed here, because in the end, yeah, it might. I mean, it's still like 50% more speed on the SPI. I think this was a good move for now. And if it's overheating, we can just put a heat sink on that. Also, what I changed, a major change, level, I can show it on level 3 code, is what we done before. We received a message, identified the target, and then sent the message and received a new one. Now we are receiving the first message, and then we are forwarding that message. It's the last words. So we forward, using DMA, we forward the message that we already received or prepared, and switching the buffers, and meanwhile also receiving a new message. So we prepare to receive a new message while we are sending, so the two SPI peripherals are working interleaved, and only like a few cycles shifted, not like completely. Beforehand we had like exclusive that and that and that and that, and it was always like a loop waiting for the message to be completely processed. What we're doing now is we sending the message and receiving it, and then completing basically, oh yeah, is it already sent, then deassert CS, and then also if we client transmit receive, we complete basically the cycle, and then it will just continue. So this is working way better. We're saving 50% of the time which we are idling, more or less, because we can directly transfer forward the data, and we have no like awkward, yeah, maybe. So this I propagated this change up to level 1. I don't know if level 1 has also this change. Let me check that. Main. At least I really, yes, it has the change, but no, it's actually not. This one doesn't have the change. But it also, I think, yeah, it unpacks it. We are sending 8 times. So this level, I mean, this is the slowest level, and I don't know what the prescaler actually is. This might be like old school implementation still. No, SPI host client, I don't even see the prescaler. Prescaler is 16. Yeah, so it's using quite slow transfer rate, something that is still compatible with level 0, so with the lowest level. But it's prepared. I mean, this one here, we could replace that line. And now the thing is, what did I change here? Oh yeah, I removed that. Don't need that crap anymore. So I made sure to test everything and also maintain like a GitHub, a Git commit when it was working. And now it's time to A, send data back, and B, implement a message that writes to memory on the lowest level and reads from memory and performs a function call into the memory there. For that, I implemented, even though we have like our prototypes that I made before, I made a new prototype. Let me move that. Here. No, there. So what I did is I took an ESP32 and basically that is spamming a packet over SPI to basically a CH572 dev board. And there I can directly develop the firmware and debug it easily, because hooking it up to the oscilloscope is quite difficult at the confined space on the blades. But here I can directly hook everything up, and let's see what's happening there. Alright, I will turn off the other stuff and we will see what we are doing here. Let me zoom out a little so we know we have a good view of the scope. And this is still the cluster, the ultra cluster. We can turn that off. I think we don't need that. Can stop that. It was just for your update. Okay, now we have a little bit more silence. And I will plug this one in, and now I'm using the ESP basically as a input. I could easily, I mean, it's easier for me to just use an Arduino thingy to set up like a test message or something. What is going on here? Where is this? What is this crap? Oh yeah, that was my power that I don't need. Okay. Oh, this is interesting. So this one goes floating here. Oh, that's cool. So whenever SPI is done, it floats. But I want, yeah, let me check that. Here is a test message. It's a little bit weird. Anyways, you can see I have like this is, why is this one blinking? That one shouldn't be blinking. Might be an issue here. Not sure yet. Maybe it's in a boot loop or something. That's weird. No, didn't see that before. Something's happening on that one. It shouldn't be blinking. That's new. Okay, let's debug it and then see what happens. Do I have it? No, power should be alright. Maybe it's browning out or something. No, it's weird. Okay, it looped over, so it's not rebooting. I'm wondering why it's, oh, you can't even see that. That's weird. Maybe it's because I'm restarting the PWM at a bad moment, but I wouldn't. It's weird. Anyways. Oh yeah, actually there is something up. We can see it here. Can you see it even? Let me zoom in on the scope. So the SPI of the thingy is not full duplex, and it has like this 8-byte FIFO, and what it does is basically it switches the bytes in the FIFO. It sends the bytes that are already in the FIFO to MISO, and takes the byte from MOSI and puts it in that position. So if you just preload the FIFO with 8 bytes of your next message, then during the next transmission that you get from the host, these bytes will be pushed out. The issue is here, you can see I'm sending hex 10, 11, 12, 13, 14, 15, 16, 17. But it seems it's a little bit weird. I also see the message up there is somewhat broken. I think there is, yeah, I think this one, we have a connection problem here with the breadboard. Some stupid, maybe a stupid let me, oh, it looks really it looks really weird, the level of 2. Okay, so this one here looks weird. Let me remove that. Nope. why. That looks like, huh? Actually, that is the issue, but I don't know. I don't know why yet. Breadboard. Ah, now I know why I hate breadboard. Breadboarding stuff. Okay, let me add the clamp here. Okay, let's work with that. What is going on with that one? Oh. Oh. Ah, okay, no, the signal is alright, we just scaled out. Why did it happen? I think there is an issue with because I set this up. No, oh, SPI. I set it up correctly before, Mosey. Hey, why is the threshold? It changed. Okay, now it works. Probably the other thresholds are also. It forgot about the thresholds when I restarted the thing. Threshold. No, this one is right. It's so weird. Okay, but we can see now the message is clear. Peeks in. Hey, Mr. Wu. So the message works fine, like the Mosey message looks alright. It's just counting up R and G because we have only those two LEDs. But what we are receiving back, it is like only 30% of the time correct. Yeah. So that is what we will face today. Fix that. That's in the code here. Okay, so what I did before is basically I switched the FIFO direction, shifted in the bytes and switched it back, so we will be receiving bytes again. Okay, I don't know if this one here, this one waits. Okay. FIFO count. Okay, this is when it's empty. I'm not sure how to set this up correctly. I asked Gemini, of course. Let's check that message. Do I have it somewhere here? Okay, before I dox myself, because I already can see that there are like private messages and my emails and everything on display. I need to move those windows away because they will, even if they're minimized, they will show up at some point for sure. Okay, we don't need that. Where is it? Looking for my Gemini stuff. Huh? Here. Okay. Okay, okay, I want to use DMA as well because currently we are just clocking in the peripheral from the FIFO, and the setup, I think I have that already. I will compare the code to what I have right now. Then there is like the preload TX. Let me check what they change. So SPI DMA enable. Okay, that's happening here as they did disable it. Then it prepares basically okay, it just echoes back with incremented values, which is quite cool. RX buffer. Okay, it prepares these buffers again, packet size. But wait, this is preload TX. Where does it load the TX in the buffer? Sears. Might be slop here. Okay, I asked it to do it. Do it on CS, but this is, I don't see how TX buff is used anywhere. So this might be slop here. That's RX. Yeah, it's not doing anything. Okay, let's check the code here. Prepare next transmission. No, it's the same. Okay, it doesn't do what I wanted it to do. Yeah, let's ask it. It's Flash. Hey Avra. Where is it set up? We have only TX here. DMA is only TX. what is the line? Let's ask what is the line where DMA is set to TX buffer? Ah! Oh, interesting. I'm wondering if that actually... No. Huh? Same RAM buffer using separate TX if your specific driver setup requires. No. DMA begin. I bet this is not true. Okay, let me check that. I hope there is this full AI slop. I need to really check that. This register description. SPI DMA begin, DMA end. There is no RX whatever because it's not supporting full duplex mode. Oh, ITT, what is the issue? So mode 0 and mode 3. SPI is a full duplex serial interface with host, and only a pair of host and slave is communicating at the same time. Usually SPI main features. What is mode 0 and mode 3? This is I think the bit order, or what is that? Can someone explain? 8-bit optional blah blah blah. Half of the system clock frequency. That's weird. I saw glitches when it was polarity. Ah, yeah. Support DMA. What is the command mode? As a slave, it supports command mode, but I still don't know. Like, you get then a command and then data. It would be interesting if we can actually achieve, like, if the command mode would add to our implementation, like reading, writing memory. That would be cool. Okay, FIFO direction. Well, I saw something, it's not actually full duplex here, usually. Blah, configuration. Direction. Transmit. Oh, okay. In 2-wire mode, 3-wire mode, 3-wire optional. Start transceiver, buffer, begin, write address, and it is recommended to set after setting FIFO direction if SPI total count is confirmed as 0. Enable DMA function. Okay, so you need to wait for total count to be 0 and then enable it. Data transmission. Okay, we never sent the length of the data. Write FIFO register, write the data to be transmitted for if FIFO count is continue. If DMA is enabled, then it will automatically load FIFO to complete this step, okay? As long total count. This is master. Data reception, blah blah blah. Slave mode. Oh yeah, here. Shoot. We're in the slave mode. So blah blah blah. First byte mode, select the slave first byte mode or data stream mode. They mean the command mode here. Configure direction. Mosey output enable, output and set to 0 and meso to 1. Meso set the configuration register to make Mosey pin as input. Meso as input, support connect multiple slaves under the bus. Meso will automatically switch to output after chip select one mask, blah blah blah. Okay. In SPI slave mode, the I/O pin direction of Meso can be set as output to by GPIO direction configuration is automatically switch to output during the period of valid SPI chip select. Okay, yeah. But this output data is selected outputs SPI data when it is 1. Puts the GPIO data output register when it's 0. Interesting. Meso as input. so that Miso does not output chip, blah blah. Okay, that's clear. 2-wire mode. In 3-wire mode. And output pin as output are realized by Miso half duplex, and directions manually switched. Okay, that's in 2-wire mode. Optional, the preset data register is load the buffer for the first time after chip select for external output after 8 clocks. The controller will obtain the first data byte command code sent by the external SPI host, and the external SPI host obtains the preset data status value in SPI slave through exchange. That's a weird mode. You have like an extra byte that is maintained somewhere else. With 7 off will be automatically loaded into Miso pin during low level period after the SPI chip select is valid for SPI mode 0, blah blah blah. It's so complicated to read. It's just like a block of text. The external with obtain preset value, blah blah blah. That's usually a busy status is provided for the host so that the host can quickly query. Optional. If DMA is enabled, it is needed to write the start address of transceiver buffer and write the end address, not included. It is recommended to set SPI DMA enable after setting FIFO dear data transmission. Okay. Write multiple transmission data into FIFO register, and external host tenants take it away if DMA is enabled automatically. Okay, that's what we know. FIFO count is not full, continue to write data, blah blah. Okay. Set data reception. And what's about full duplex? Current FIFO direction is in as input. Not the data has been received, and the data will be taken away by reading. Complete this. Okay. So no mentioning about that. You know what? I will switch. Oh, that's flashlight. Advanced reasoning Pro. Keep the typos. I don't know why it's small. It's thinking. It's chopping down trees to figure out my stuff. I'm wondering if it's actually using the same buffer to receive stuff. That would be interesting, actually. I'm wondering if it was also the issue with when you transmit from let's say from a constant buffer, that it wouldn't be able to write to that address. Searching web. Okay, let's see what it finds. We can answer now. Let's let it dig. Hey, thanks ITT. Okay, you know what? It's not. I'm wondering what's happening when I'm. Okay. Huh? Where's my? Okay, the dynamic. We're pointing. Clarification. Yeah. Data corruption bug in full duplex mode. DMA buffer conflict. As clock edges arrive from the host, incoming Mosey bytes are written into, because both operations write and read dynamically, attempting to copy data from TX on CSDR set requires specific handling. Okay. I'm wondering if it's actually the case. We should I need to verify if the same buffer is used. It would be really weird because, oh, you know what? I will check if there is a new datasheet, first of all, because we might have missed things. Update. Nope. There's nothing new. The environment, the development environment is also same. You know what? We can also check if Charles has this CH32 fun has here. Wait, is there another fun? Yeah. If that they have an implementation encoder timer. LCD, SPI, TX. It's only TX here. Okay. Chip select, DMA, SPA total count. Interesting, they start by setting just the number. So DMA is enable, DMA begin, DMA, SPI DMA loop, and enable. So that's a quite cool method to implement that. So we circle through the buffer. What we can certainly try is, you know what? Let's copy. Do I have? Yeah. Let me get. I have the DMA implementation already in my code. We can actually try to reflect everything. Level 0. Okay, so this is RQ handler. That's doing something, but this is not what I'm looking for. So the interesting things I didn't even talk about yet. Maybe I would show you as well as a short intermezzo. So the link file, it's quite interesting. We have like the high code. The high code is copied on startup. It's copied into RAM, SRAM, and a render. So we have 12 kilobytes of RAM, and then it determines. Yeah, here is some high code, blah blah. And basically, what I let that actually works. I wanted assertion here that the code that I'm loading into SRAM isn't bigger than 2 kilobytes, and this is what it actually does. So my plan will be in future or today, I hope we can do it today, will be to, we have the stack pointer here. This is our stack, which is growing in this direction. So this is the whole RAM. And this is our RAM. Then we have like flash is somewhere there. This is flash. Flash. And this is the SRAM 12K. And what I want to do is we have like functionality for our communication for the bootloader. So what I want to do, we have like some sections of that, like of the code. Some sections of the code are copied into high mem, like that. And what I want to do is, I actually want to limit this to 2K. And or whatever that is, I mean, the best would be actually to put it somewhere, since it will probably not be like a round number, to put it towards the stack, or we put everything like the stack here. We can do that. Let's say, but I also want to be controlling of the stack as well. So the remainder, like 10k, or let's say, let's save 2k for the stack if we have like some deep recursion with big stuff or whatever, or memory. Let's leave it there. This is our memory and stack, and then 8k would be for our code. So that would be our stuff here. Does anyone have a better suggestion? How do we split this? Because I want a specific configuration file for our compiler, where we have defined a function that starts exactly at this address in the end. And I don't know if we can actually do this. I hope we can. Specify that this function is always first, and like a loop, main loop or whatever, call it loop. Shit, my mouse. Let's call it just loop. Okay, so the function is here, and all your code, everything is also in this section. So we mark this all as that stuff, and it is placed in the specific address here. And what our bootloader does, we can write directly here, because we know this loop function is always at this position. Our bootloader can basically write to this section, which will be 8k, and maybe more if we have if we use the RAM, share it with the stack. We could also check if what is the lowest value of the stack pointer, so we actually know what area to protect for our bootloader to be safe, so we never overwrite it. I mean, but at least not with the bootloader. But then we can just reload, we can compile a new code, and then we take the binary file and just send through the cluster whatever is in that 8 kilobyte section and upwards. I don't know, the data section can be above that. That is interesting. I never configured the linker to do stuff like that. Wondering how. Let's try doing that. Actually, I'm interested now. Is it here? Okay, GCC configuration. How do I create a section at a specific address and make sure that a C function starts at the beginning of this section and all functions marked are just stacked. Also, I need an extra data segment with that starts at a specific address. Give C++ and LD file example. Give, or let me do a simple or minimal example would be interesting. So we are not sidetracking. Oh, the pro version is really slow. Okay. Custom code region. Data region, custom data region. Okay, so this is the memory layout. Standard text flash. Okay. My custom code entry. Force the entry function to be placed at the exact beginning. Okay, that's interesting. And did anyone worked with something like that before? Stack all other marked functions immediately after my custom code. Custom code region. Custom data. My custom data. That's interesting. That looks really simple. And I'm even wondering if we could. No, they're like API functions that are in high code. Also, interrupts are also high code. So, if we want to work with interrupts, we can't avoid the high code stuff. And also, we need another data section. So, C code. Code start attribute section. Okay, section code, section data, section data. Oh wow, custom code segment. This actually looks promising. I like that. Let's record that. So this is the configuration. If we make a video, I need that. This is the configuration, which forces code entry to be at the beginning of this section. Section has a specified origin and data region as well, and then this is just marked, the function and data is marked with our attribute. The only thing that is missing here is the same stuff that happens to high code, which is basically copying that from Flash basically the stuff from Flash to this section here. But we can just take the same stuff that's used already there. So let me check that out. Linker script, high code, init alignment. What is init LMA? Add flash, high code, add flash. And then there is the high code RAM and then add flash. So what is okay, let me ask him that. Okay, this is interesting. This is our init code, and I think this is the assembly that we got here. Huh? Huh? What? Huh? Oh, here. Sorry, this one. Okay. Start init section. Here it is. So this is certainly, this is also placed the same way. And then it loads the address in Flash start end. No, address LMA VMA start and end. VMA, is that the address in, I think this is the address in the memory, and then it copies everything. Byte load TU unsigned, whatever. Load data section from Flash to RAM, LMA VMA data. Okay, that does that stuff. Okay, so let's ask it. I have this example. The start up code copies the high code into the memory section. Oh. Okay. A little distraction. We will just continue with the DMA transfer in a second. Ah, yeah. Linker symbols. Align 124 in the high code section. Records the flash address before high code starts. Inside hide advances both the RAM VMA and flash LMA pointers to a 1 kilobyte boundary. It's captured before the byte alignment, while the actual code vector starts after. Interesting. So Gemini might have found a bug with the alignment here. It will basically, it can mean that I don't know if it's BS, but the alignment is done after the vector is stored. So you might be, it's always shifting forward, start, so it will basically copy a bigger section. No, that's not an arrow, because you want the start of the code. Wait, high code LMA, high code starts. It won't just to extend. I think it will just to want to extend the section to the nearest 1 kilobyte border, but let me check that. It would be interesting to see. I don't know how to read linker scripts yet. We can check it, what it means. Okay, it aligns it at 4 bytes. That's our init code. Keep sort non init. Okay, whatever. Init, whatever that means. High code init align. Provide high code init LMA. Okay, so it aligns the init align init LMA lower memory address. No, or is it? What does LMA mean? LMA is load. MA is memory address. That's for sure, because what is VMA? Virtual memory address. High code align. That's in the flash. Flash, add flash, RAM, and add flash. Provide vector high code align. Is this vector? Is this the vector table? No. No. Section vector table. I'm a little bit puzzled. Okay, I don't need the actual alignment, but let's continue. Modern bug-free alternative. So using dummy wrapper sections like high code built-in load address directive to align the section header directly. Oh, code snippet. High code align. Ooh. That's cool. That's an alternative without all that crap. VMA start, VMA end. Cool. It's basically, since we have packed code, which can be like, it doesn't need to be multiple of 4. It will align the pointer. This is interesting, because this is actually I interpret this how everything is packed, and what it does here, it provides the current address and then packs in section vector, increases the pointer, then it packs in high code section and high code star section, then increments the next like alignment of 4, and then provides the end, and the stuff is then just copied. And RAM add flash. That's so cool. Why is this? Okay. Okay. No, I don't want to. Explain. We learned something. Linker scripts. Never knew that. There it is, LMA, load memory address. So, where the, I can't read. I can't read it. Oh, here. Where the code data lives and runs while the program is executing, all function calls, pointers, and variable addresses are linked to this location. Okay, RAM, and this is basically at flash. Okay, interesting. When the code data is written permanently, when the program, microcontroller, debugger, flasher, blah 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 blah. The CPU executes the code out of RAM BMA, enjoying full speed or RAM only hardware privileges. Common. That's interesting. Like security wise, if you imagine there you have like some malicious code on I don't know, data or whatever, JPEG, corrupted JPEG file, would never be able to use a buffer overflow to execute something like crucial flash writes or whatever, security issues. That's my guess. Common cases initialized. I mean, you could always copy it somewhere to RAM and then jump there. The initial value data lives in flash, so it isn't on power. Let's see if we modify count in the RAM while running. Fast code, high code. DSP interrupt service routines, blah blah blah. Cool. Lessons learned. Okay, we will actually modify it and see how it actually performs later. Linker script, check. Very, very interesting stuff. What I really wanted is this here. Okay, receive SPI client DMA. That's data and the length and total count, blah blah blah. So let's use that. Receive SPI client blah main loop. While I don't think let's call it old and do a new main loop here. Oh yeah, we need high code. I want to see if what is happening when we are using data. Okay, so we have data here and 8. 8 is the bytes. I want to know what happens while 1 oops. Data 8. Let's preload that with 0, 1, 2, 3, 4, 5, 6, 7. Transmit it. No, we receive data. Hey, Peter! How is the weather in Boulder, Colorado? Okay, let me check what this does here. It should be working. Let's upload it. Yeah. That's what I thought. It doesn't. SparkFun is in Boulder? Yeah, it does nothing. It is basically we get an echo from the FIFO. But you know what is weird? Even though we do nothing to the FIFO, it somehow is shifted sometimes. Oh, this is weird. I need really the external interrupt. There's no way this is actually doing anything. Like we're not preloading anything. It's not outputting stuff. Let me change. Let me change the direction of. Let's just transmit. Oops. Let's just. Germany was cold. It was all the time below 20 this week, but tomorrow we get 30. So I hope we get some more warm days so I have enough time to implement my heating system. Okay, so SPI, let's do that thing. Wondering what happens and not dear data length count oh, it waits even for stuff to happen. Okay, let's see if that actually does something. We should see on the output. Yeah, that's not aligned at all. We get the output, but it's not aligned, and I'm wondering if we can make it align. So what is the issue? If we transmit it here. Okay, we should do like GPIO interrupt. Where is it? What? That's I mean, they are competing with all the other like prototype boards manufacturers out there, like Seed Studio and so on. That's hefty. It's still like, is it minimum wage or what is it like payment wise? Do you even have minimum wage? Yeah, in US there is minimum wage. Is it? Or how well does McDonald's pay? Yeah. Oh, too little. Yeah, you have to 45 for the zombies or aliens or whatever that was. Um, I didn't give it much. What? $7 minimum wage. This isn't the 80s. Okay, let me think about it. Okay, I was paid. The lowest I got ever paid was like 10 Deutsche Mark, which was like 5 euros 20 in the 90s. And I was working like filling the shelves in the grocery store. So that was like the lowest tier job ever. And I instantly increased like by switching to like storage room, like stacking boxes for $12, which is more or less like 7 Yeah, that would be $7. Oh, that's hefty. Then $19 to flip burgers. Ah, damn. I would flip burgers for that money. One for you, one for me. Hop. One for you, one for me. Double smashed burger. Mmm, with roasted onions. Yeah. It's not bad, I mean. But I believe it's on at 12. Yeah, 12 mark is what I got as well at some point. And then you know what is funny? I don't know how much did I get. I think it was also 12. Uh, I was I worked at when I was still in school. I worked like maintaining the cars of a software company actually. And at that time, I was already like coding my free time. I was coding games and so on. And yeah, I was doing that like for $12 an hour. And after I think a year or something, they asked me, one of the managers there, what are you actually doing for in your free time? Do you have any hobbies? I said, oh yeah, I'm coding. And that was just around the dot-com bubble. So just before that, in the end of 90s, I think it was 98 or something. Yeah, it must have been 98 or 99, round about that time. And then yeah, yeah, and then they said, "What? Why are you why are you buying groceries and maintaining the cars here? We need coders." And then he asked me, "Okay, so yeah, you can have like a coding job here. What do you want like for salary?" And I shrugged. I didn't know what to ask for. And I think they proposed, yeah, okay, let's start with 18. And immediately after 1 week or 2 weeks, when they saw I actually am capable of coding, they raised it to 32, yeah, $32 an hour. And yes, that was amazing. But yeah, I had to, I think I had to pause for my military service. After that, I also during university I worked there, but that was actually then I couldn't work anymore because I was earning too much. And I was like so cocky. I had a team of two people and so and I was so cocky. I said, "Okay, if I can't earn any more, because they would get like in trouble with the IRS. Uh, as a student, you can only like earn like a certain amount. Like you need to be below the time that you're working is needs to be below 50% or something. So you're not like a full-time worker or whatever for taxes and everything, and I think for social security stuff. And they said, "Oh yeah, we are in trouble with that and we have to figure it out." And I said, "Okay, then I quit." Yeah. So I just quit from 1 minute. Yeah, I'm feeling sorry about that because I mean I had like some connection there, but I just quit and went home. I just hit the limit of what I can earn for this year. So I said, okay, if I can work, or I don't know, I won't be like paying taxes now or whatever. I just quit and then start over in the other city where I was actually living there and going to university in Darmstadt. So, but Vilbe and Darmstadt was a commute of I don't know. It took me 45 minutes to drive. So it was quite well paid, and then I just started again with I don't know what the regular student salary was quite low. If it, and I think, and then I worked for. At some point, I had a job for 1,000 around. I think it was 950 bucks a month, and I worked 10 hours a week, more or less. That was what I supposed to work, and it was sometimes less. I don't know, depending on how much I had like to study or whatever. Which what was enough? 950 bucks was enough to pay rent for a room, um, shared apartment, and I had to pay like only the 50 bucks or whatever. Yeah, that were the times, and I was living off. I had enough to like buy a car, a crappy car, but I still bought a car. I learned like I took paragliding lessons. I bought all that stuff, computers. I bought computer equipment and everything, and that was enough money back then, like 1,000 bucks a month. Uh, and now I need just like 1,100. Yes, I am. Yeah, ex-pilot. Yeah, I'm not. I didn't fly for quite a few years already, but I think I could warm up quite quickly. But not motorized. I don't know. Typically, like in US or whatever, you usually do it motorized. I'm not doing it motorized, so only like if you're from US. Looks like you are from NASA. So so the rocket propels. Try it. Fascinating. Free flight. Yeah, free flight. Oh, Brazil. Yeah, that's quite popular in Brazil. They are like kamikaze flyers. I saw a lot of videos from Brazil. I mean, you have also like nice landscapes there to fly around. Yeah, and that was that. And now I'm not even paying rent, and I still need like 1,200 just for my fixed costs a month. I don't know. Life got expensive. Oh yeah, one comparison. Uh, the groceries for 1 week of living, I because I was so frugal, I saved up for all my nice stuff. I just ate like shit. I like uh, pizza and stuff like toast, and I don't know. I lived from 15 euros a week, so a total of 60 euros a month on groceries. This is a bit, yeah. So story time over. Uh, Now I I live. I get a salary of what is it? 2 cents per hour from YouTube. Oh, I can tell you. So list. Uh, yeah, you got like frozen pizza margarita. I bought like a salami sausage and like frozen 3 pack of pizzas was like $2 or $3. That was like for that was enough for 3 days. And then I added like slices of pizza on top of it, so it was really drenched in fat and oil. And I think I even put some extra cheese on there or tomatoes or whatever. And then for vitamins, I had like these tablets that you dissolve in water. They were cheap, like 70 cents a pack, and it was a pack had like 20 tablets or something. And then I ate probably toast with butter and cheese or whatever. Yeah. Hey, Angry Tomato. Are you living in Darmstadt? Yeah, not anymore. Yeah, now you have to go to Tegut now. You know where that was Penny. I was eating only stuff from Penny. Toast with ketchup. No, I not really. Not really like it wasn't as terrible. I mean, I had like stoner meals, greasy something. Darmstadt. You don't eat anymore? You drink tea, Casper. um, so I had like I mean I had some months where I bought like my paraglider, which was 3,000 euros. So I had like to pay that off in three rates, which is yeah, as you can imagine, I think I prepaid some $1,000 and I had like to pay off 600 a month. And I paid like 350 for my rent, so there was not much left for food. And at some point, I didn't have anything to eat left. My account was at 2 euros, and I basically bought yeast, flour, milk, and then like the cheapest like packed salami that you can get for like 70 cents at that time or whatever. And I bought that like for 250, and I thought this will last me 3 days. And I made like a huge pizza out of that, which tasted terribly because it was only like tomatenmark or whatever on top of that, and barely any cheese that was left over. And I ate the pizza, which was very thin. Tobacco. Oh yeah, you smoking. Oh no. Hey, Basil. And the pizza was really thin, and I thought, oh, that will last me 2 days or 3 days until I get paid from my work. And I ate the pizza, and it was basically gone on the same day, and I was really hungry. And the next day, I think, you know what I took? I took just whatever was in the cabinets. So it was sugar. I put sugar and milk into a pot and heated it up, and made like caramel, which basically tastes like Werthes Echte, if you know like the sweets, the typical German ones. But it's basically caramel, and I made this mess of caramel, and then poured it onto plate and let it cool down, and I ate that for one day. 1.5 days. I had only that to eat. And the next day I got paid and I could afford more stuff. And what I calculated, the best ratio, a form of art, yeah. Yeah, you can probably pull like strings out of that. The best part was student times, yeah. Best part is Back then, nowadays I recalculated, I checked my calculations, and they are not valid anymore. So don't try. Or you can maybe how you survived. I wasn't very healthy, but all right, I mean survived, and that's why I probably don't need much, or I don't expect much from from life. I can live frugal. Anyways, my calculations back then was okay. What is the cheapest food for calories, like price for calories that you can have? And of course, I mean, you won't be able to drink oil because oil was sunflower oil or whatever is 800 calories per 100 milliliters, something. You can't digest just oil or whatever. It's not like, but um, better was speculatius. That are like cookies, Christmas cookies with cinnamon and whatnot. And the package, like the cheap ass from Penny, the cheap ass packet was for €1, or maybe even below €1. I don't know what the prices was, but it was 600 grams, and it was 350 kilocalories per 100 gram. So you could live off like €1 a day or whatever just by eating cookies. Yeah, so that's what I that was like my that were my thoughts and thought processes back then. I never thought of like eating what is it, Haferflocken. What's the English word? That's probably the cheapest. Oatmeal, yeah, oatmeal. Yeah, it's oatmeal is like I don't know, it's yes, cereals, but cereals are quite, I mean you can still like cornflakes or whatever, they're like cheap ones. Yeah, actually cornflakes you could get like for $3, but it's also like only 500 grams or something in one. Rice and beans. We work yeah, basically that. So Biscoff, yeah. Uh, yeah, that was the student times. So my priorities were my priorities were like my fun time, spending. Hey, Quindor, you missed story time from my student days. Um, yeah, but that's things I will never forget. I mean, that's why I didn't care when I was. I mean, I learned it also from military service when we had like uh, during the first like 2 weeks or whatever. They sent us like to the forest, and they brought us food that was basically um, a piece of bread which was drenched in rain water. So that's what we got for one day, and I was like, seriously, that's what we get for to eat for today. Anyways, let's do more codes. Wait, yeah. Uh, we have misaligned transactions here. I asked it to give me code for interrupt. GPO pin 4. I think that's the one. Okay, that's chip select. Let's clone that because that looks good. Entry point, interrupt fast. Mm, We can put this also in high code. Okay, because I want to basically start the transmission. It looks like data is not really aligned, so I will start that part whenever we initialize init LED, init SPI client. Let's do that. Yeah, we had some slop today actually. In it, we had some slop today already. I don't need that. Chicken. ITT. Where do you get cheap chicken nowadays? There is no cheap chicken anywhere. Yeah, Caspar. So do you have like to work with AI every day? No, you are like a technician. Aren't you a PC technician or a computer technician? You probably have like to set up as well like some interfaces or like stuff like that. Do I remember correctly that you have been a technician? It tried to tell me that PC is an RQ1 and A20 pin. What? RQ1 and the A20 pin. Oh yeah, I don't. Wasn't that a hack like A20 a address? Oh, there is no address 20. It is only 1 MB limit, wasn't it? Oh, you're working with ESA. What are you building, Basil? That sounds interesting. CSA4. Oh yeah, we have A4 in pull up. It's already in pull up. So we don't need that line. Serial to mouse, USB mouse interface. Are you working with an old PC? What, where do you get? I use Gemini for comfort. I was disappointed with the performance. I should check now what, like I did ChatGPT for some. What is 16550 compatible UART? What is 16550? Oh, that's the UART standard. But where do you have like ESA bus? Ah. Okay. GPIO ARQ. Is this like a definition? Yeah. Entropy, I might be. ChatGPT, I was disappointed, wasn't good. I had better results with Gemini, but today we got some slop. That's the first time. Okay, Cloud Code. Cloud Code. Okay, let's start with Anthropic Cloud Code. Reject all cookies. How do I try Claude? Yeah, docs me. Okay, cookies. You know what? I don't need to give it. I don't want to download. Yeah, well, enter your name. Oh, what engineering here? Or is it software engineer? Evaluate, no, software engineer. Plan refactors. Where's my prompt? Here. Which models? Sonnet 5 medium. The medium is default. We can. I don't know if I can. This is test version. I don't know. Probably it will limit me at some point. So not sure. CH570 chip. I need full duplex SPI packet size 8 DMA if possible. Here we go. Let's see. Did it find any full duplex example code? This is wrong. It passes the wrong files. There's like a max 7219 driver. No, not 568. This is wrong. Okay, it found on LCSC some datasheet. Yeah, maybe it learns how to do SPI right now. Let's see what it does. I'm curious. I'm open. Spoiled kids. You all are spoiled kids. What do you pay for the super mega model? Wait. Can you run that on CPU? I have I have 128 gigabytes. So you is it aren't they like new optimizations that can how do you download 100 gig? I don't know. I don't even have 100 gigs free. Wasn't there like optimizations that 20, then 100, then 200? You pay 200 a month? Yeah, I have 128, so that will be all right. Ah, okay. Yeah, let's see. Uh, byte polled via buffer goes out on Mosi. RX buffs. Okay, wait a second. Let's see. Let me change to dark. Oh no. No, I wanted to change the. Where's my. Where's my. Go back. Okay. I'm too stingy for that. Okay, wait a second. Let's start over again. So, stay SPI. This is like completely wrong chip. Control mod if else. Yeah. This is trash. They share the same SPI IP block. Oh, okay. That's a good hint. I don't have the exact PDF. Oh. But yeah, whatever. Okay, let's code regularly without spending 200 bucks on the license there. But that's interesting. If it works for you, you can regain 6, 7. I have chocolate. Where's my chocolate? Here. We have some great. What is it? Rosinen und Nüsse. Claude. Okay. That's cool. So I might even. No, I think I threw it away. I had like peripherals that had like a serial port, a trackball that had like a serial port. Nice. Cool thing. Okay. Let's do that. Let's remove that crap. Enable IQ handler. Didn't we have? Let me get my Chat GPT code. It doesn't clear IT flag. How does it do that? Is this like how it's cleared? 2 writes? Oh, come on. Oh, where is it? Okay, this is reset of SPI. SPI all clear. Oh yeah, that's the interrupt flag. Okay. Root message. Oh, interesting. That was like my message receiver. Maybe I should keep the function as it was. Basically, okay, let's copy just wondering, there must be somewhere the code to activate that that thing. Yeah, it's checking where source flag. Yeah, we want to see if it's falling. So yeah, it's basically how do we read? Do we compare it? R8, R16, GPIOA? No. I don't know how to how to read this. This is this like mode config, IT config? Okay, this is correct. Looks like either we no common isn't included here. SPI. Let me check that. Okay, go to definition. Let's check. PA pull up direction. Okay, go to definition. Pin. PA input byte R32 PA pin. Okay, this is what we want. We can even use R8. Let's use that. It's 32-bit CPU, so use it. Yeah. So, no, wait, we are asserting it high. So whenever it's done, flank up, we do whatever. Oh, this is. We clear everything, SPI control, whatever that means. SPI all clear. Okay, interesting. Direction, no, what we want is we want SPI CS init. That's that. Transmit. Freaked out? What does it was that what does it mean? Okay, I will prepare an output here. Packet size, SPI packet size is 8. Let's do that's our, or let's say packet, let's make it safe, packet Okay, so we clear everything. We start to transmit. Now everything should be aligned. Set, receive, SPI. Okay, we don't do anything here. Everything happens in the interrupt now. Let's see. Yeah, thank you for nothing. It does nothing. I don't even need to switch. It doesn't transmit anything. Ah! Not me. No. No. This. Does it even go there? Okay, you know what? Let's start debugging it. PWM shaped curve for powering a giant magnet. Okay. Where are you working, Peter? All right. Wait, let me go. Does it even go inside that? Does it ever enter this? Oh, I think we'll... Really? Oh no, okay. I think we lost our connection. Something went wrong. Something went horribly wrong. No. Yeah, look at that. Falling edge. Never does falling edge here. Interesting. We never enter the code. We don't enter the matrix. Fall edge. You know what? This is configuring everything we need. Fusion? Magnet. Oh, so that's not like laser fusion then. It's, or is it? Is it laser fusion? In Boulder, Colorado? Oh, you do, okay. I won't do it. Okay, let's not do it. But I'm still curious. Yeah. Let me check something. No, in stalker mode. Oh, interesting. No, that's too far away. I mean, okay, I won't ask too many questions on stream. I'm curious what, but yeah, we'll see. Uh, yeah, okay, I don't need to actually check anything because that's always only entering there on falling edge. I'm still wondering why it's. Oh no, I need a rising edge. That was the issue. Okay, okay, okay. So I don't need. I could check it, but I actually don't need it. Not fall edge. I need rise edge. Yeah, curious like a cat. Yeah, basically. Um. Yeah, let's do that. Keyside. Wait. Oh, yeah, that looks like. But it's still the same issue. Peeps, it's still the same issue. Sometimes it's lost. What is the frequency right now? It's not only 2 megahertz. Why are we losing? Something's off there. And we have enough time in between the packets to process everything. It's rising edge. I don't know if I can trigger conditional trigger. There it was. Okay, it was the last byte. Then we had a 0. 0. Okay. I don't know why this was happening. There was a 7, so we had. Okay, we have some shifts sometimes. Sometimes we have. Yeah, I probably can. But I see we get sometimes no data at all, zeros. Then we have. Yeah, some shifts, either in one direction or in the other direction. So what I can do, I can try to do more to clear the SPI stuff here. So transmit clear, all clear. Okay. Let's check the datasheet. How do we reset the thing? That's the FIFO direction clock idle. Master slave control configuration. Okay. Oh, that's interesting. Input delay in master mode close to a ho ho ho. That's interesting. Okay, SPI blah blah auto if DMA clocks. Huh? What is the flag that we're all clear? Interrupt on a byte, and this is like super slow SPI if you use an individual interrupt on each byte. All byte transmission completion interrupt. That's interesting. Half FIFO. FIFO overflow. SPI control mode all clear. Control mode. That's config control mode, and then it's all clear. Counter interrupt flag clear. Force to empty and clear. One slave mode. Okay, so this actually forces it to clear everything. I'm not sure why we still get the shifts then. Okay, let me try to do it on raising edge, or let's remove that crap. If we have some bouncing or whatever. So it will just do on the... Oh, wow, interesting. Now, look at that. Now we have the bouncing and the shifts and everything. Is the chip select so terrible? That's really weird. Where do I measure that? Okay. I can use this one for the chip select to see actually what we are dealing with here. I hoped we were further with our developments, but the weirdness of this thing. I want it to be really stable, because this way we don't get. Oh, look at that. Okay, the timings are quite tight for the chip select. But it doesn't look like there is any bounces or whatever. The handler is always triggering now. Oh wait, huh? Why is it stable now? Okay, I saw a glitch there. Yes, that's SPI. I'm working on the Ultra cluster and now trying to do a duplex mode for the CH570s. Okay, that looks quite stable now. But why? Was it some breadboard glitch? I see from time to time there is still a shift. I'm colorblind. Green line, yes. Yes. Yeah. But the issue is like the third line. I don't know why. That's like a pulsing. Yeah, that's also a blinking that I saw before. Maybe we get some power issues. Nope. No, it shouldn't. Actually, it shouldn't be rebooting. It shouldn't, but I'm not sure. You know what? We can find out. Yeah, we are powering it off the Linky, so let's try to do it from somewhere else. Now it's powered. Let me do it from. Do I have a USB cable here? Yeah, let's power it from somewhere else. Might be browning out actually. Not sure if the Linky power, or if this is even. No, it's still doing it. You know what? Let's actually display do on boot, or it's not stable at 100 megahertz. Working around, fixing the code, what? Okay, let's do static and counter. Then let's do package 0 equals counter packard. Yeah, let's just shift it by, you know what, we can just, we don't even need that, it will just clamp it. Or let's do it. Okay, it boot loops. Huh? At least I don't see any functionality. Oh. Flash operation? What? Fade the program, okay. Oh yeah, probably that's the problem. But I can't write now to it anymore because it's always rebooting. Wait, you're right. Can't program and verify. Okay, let's do it then like that. We power it off the linky and then power cycle it. Okay, here we go. It's still yeah, it's rebooting. But it didn't do it before. Oh. That's not good. It only manages. That's basically 300 milliseconds. But what is the issue? Yeah, that's all right. I mean, that is basically because as soon chip select goes high, it's going into high impedance mode. We could do this floating, yeah, here. We could just pull down here instead. Meso, yeah. So if we pull down here, PD, then it will not like float around anymore, but that's not the issue. The issue is why it's booting. I saw that behavior on other chips as well. I'm not sure what the issue is. Okay, let me try to change the clock speed here. If it has to do with the clock, because that would be interesting. Not ink. Peripheral. Startup. Heh. Using untested 100 megahertz. Okay. Let's try. Let's see if it's stable at a different clock speed. Wondering if the issue is like, okay, what else can we do here? We can do 75. Same. 75. What else can we do? 50. Same. This is not the issue. It's something else. We do, what else can we do here? How low can we go? At 20 megahertz. Should be still plenty of time to process everything. It's always the same amount of cycles. So it's not cycles, it's time based. Why does it boot loop? Okay. I saw that behavior on other chips as well, and I was never able to recover from that. I'm not sure what it could be. Maybe there is like some configuration or whatever that is causing that. Can we read it? Yeah, okay. Enable watch. What is IV watchdog? Okay. External reset pin. Enable reset pin, no. Enable bootloader. What happens if we disable the bootloader? Does it directly start at Is there like a maybe timeout or something? Um, no, it's solved, but we have like a boot loop, and I don't know why. It only appeared now on stream. Before I didn't have like the random restarts because I saw that now on the LEDs. I'm wondering if it's a damage on the chip or what the issue is, especially because I don't have many of the boards left. I think I even replaced the MCU on this board already. Okay, let's ask. Yeah, I could disable it at the start, but I think we tried that already. Okay, how often does it restart? Like a few hundred milliseconds? Hande. Is it brain fog? Power supply LDO Drew brown out reset. Bad interrupt, hard fault. Oh, interesting. Hmm. You know what could happen if you know what the issue might be if no, but we didn't have the interrupt before. The interrupt could, like, if we handle it wrong, here, interrupt fast, high code. If that definition is wrong, it might be that it restarts or whatever. Hard fault handler. How does that work with? Because that's yeah. Okay, let's see what it does. The reset line should be floating. Give code disabling a reset. reset and watchdog. It's weird, it's always the same time. Okay, let's try that. If it changes anything. Also, what we could do is just see if we can. We should be able to see the pulsing on the LED. Okay, let's try that. Build failed, okay. Huh? Watchdog reset config. Okay. Functional state. The other as well. Okay, let's try again. But I think we are still missing power. These are not functions from see if we can do reset config, watchdog reset config, hard fault handler. Oh, this is a 72. I have no clue. If it's the function, if the function is here, reset execute, hard fault, sys. There is no, I can't find the config for that. Okay, I'll switch the model. Okay, let me check if we can. IW off. IWDG. Okay. Yeah, I told disable watchdog. Okay, here we go. Uh, uh, let's do that. I don't need. Can I do this even? Oh, I should move. Move that over here. Let's leave that on. What do you want? Enable. Okay, yeah, that's not there. That's something else. Let's go. It's still resetting. It's probably not even on, so it's not the watchdog. I mean, we could even display the watchdog counter if it was running. Okay, here. Power. I don't think it's the power though. Let me check. This is 3.3 volts. Yeah, BCCN 3.3 volts is connected here. That's not great. If I disconnect the LEDs, nothing happens. Yeah, it's the same. Doesn't have to do with the LEDs or something that they're overloading. We had the same with power from it's ground. Let me test something completely different. Okay, so set LED and then let's just stay here after LED is initialized. It's still resetting. Still resetting. It's still resetting even if we don't even like. AITT. Okay. How do we brown out reset? We can test that by measuring. This is our. Yeah, we have hardware issues. I hate hardware issues. I want to concentrate on fixing everything else, not that stuff. Okay, let me hook it up to the VC. Oh, I'm wondering if it has to do anything with the connections here. Let me change. Okay. This. Nope. All the same. So it had nothing to do with maybe some sort of power issues across that thing. What we lost a probe here. Huh? This is the last probe. Which one? Oh, I lost ground. Here. Okay, and no matter what I do, the LED is blinking, so that means we have power issues. Okay, I should measure now the power of that thing. So let me do that. Is it? I have 3.3 volts here somewhere. Everything is entangled here. No, I need something. Let's see. Probe it properly. It looks stable to me, 3.3 volts, more or less. Yeah. Ah. Reset. Okay. Let's do that. If it's a bad configuration, execute checked operation. Okay. Nope. Okay. Then maybe the configuration is changed here. Turn off link power out. No, that's clear code flash by power off, disable code protect. No, these are not the settings. There are no settings here that are interesting. Let me read. What is the reset pin? Maybe we can just pull that high or set it high. Just to be sure that. But on this dev board, the reset should be pulled high. So okay. That is not fun, I can tell you that. Everything was working until I started the stream. Not sure what happened. Wait a second. It doesn't blink anymore. LED doesn't blink anymore. How did we do? Oh, now it starts again. Huh? Okay, now I have to check that. Reset is A8. Reset, and I need to pull this high or whatever, A8. That looks low to me. No, that's high. Oh, wait a second. It's A8 is pulsing. A8 is pulsing? You can see actually, I mean, it could be if it's resetting that, but it wouldn't be pulled up or anything. What the? What is going on? I need a different, no, it doesn't have to do with the power source. That's weird, okay. External reset pin active, low. Built-in pull-up resistor. But it's an internal pull-up resistor, so that doesn't mean a lot. What if I pull it high all the time? It's still resetting. Yeah, it's still resetting. Hey, Bamboo Cars. My ultra cluster, but I have some weird issues with my my chips. They're like, this one is resetting after every like 300 milliseconds, and I don't know why. This is like something that randomly appeared. It's really tiring right now. Reset status. Okay. You know what? Let me debug it. It will probably also do that when I debug. And actually, I'm not sure if it's still running. Now this is also interesting. I'm having this this while loop within the interrupt, which is a little bit weird, but when I test it without any other code, it's still looping. Now I need to see if it's doing it right now. It's slow. Yeah. It's interesting. It stops when I pause and debug. Okay, I have an idea. Give me assembly code in C to pause debugger. Breakpoint, yeah. You know what? We will do the following. We will check for the reason, reset reason here. Just run it. Main. Okay, we make it volatile and then we do reset status. Reset status. Watchdog count. Where is reset status? Which one? Where is it? Okay. Watchdog count. Watchdog count. Oh, here, yeah. Power watchdog timer, external manual reset when waking up from power down mode, wake up, blah blah blah. Software reset. Okay. Let's do this. Write it and then see what happens. Okay, now Handle reset. Oh, here we go. AS hex display 96. So we have 6. Wake up reset LRW, and the previous last reset was RS external. Okay. Watchdog timeout reset. Okay, interesting. We run that again. Now it's 6 again. 6. Oh, now it's stuck. Stuck here. It might not read the A again. Now it's 62. Wait, 6. Oh yeah, I need to change that. Yeah, no, that's correct. It's the same value, 62. It's always that. What happens if we disable the bootloader? Shouldn't it just load perfectly fine still? Because if there are interrupts, some weird configuration of watchdogs, interrupts, whatever. Hardware, okay. Faster startup, risk of soft breaking. If you disable, lock the debug pins in your application code, you will be unable to program the chip without executing a hardware must erase or over. Okay. I mean, I had that before. Okay. I can also try to disable interrupts and run into this while loop, but we have still PWMs running here. That's LEDs, WM. Disable all IRQs. Okay. Oops. Sys. What is this void? What is volatile fence? Hmm. What happens if I do that? Oops. Nah. When I pause the execution in the debugger, then it does nothing. Okay, at this point I'm really I'll try to disable the debugger now. I mean the bootloader. And let's flash it. I have no clue what the issue is. Oh yeah, the stack pointer shouldn't be the issue as well. Unless it's just the definition of the interrupt here. If we don't define the interrupt, maybe the structure of the... No. Nothing to do with that. It's so weird. The chip is destroyed. I don't know. This would be like the third chip where this happens. I can't have that happen to my blades. Switching chips there is nearly... It's not impossible, but... Okay, Basil, thank you very much. Yeah, I will continue today until I find a solution or pass out. Oh, it's already 12 o'clock, okay. I should be passing out right now. I'm quite tired though. So... Sleep is good. Yeah, I can come back tomorrow and there are no resets appearing. This would be... Two separate are active: simultaneous watchdog reset and external pin reset. Are sticky. They accumulate across reboots and do not clear automatically. A value of 6 means the MCU has locked both a watchdog timeout and a hardware pin power reset over its recent boot cycles. So the physical reset line went low, or a severe power glitch dropped the voltage supply. Watchdog forced. Okay, let me do the following. I will just disconnect this and that. So that's a cold start here. It's restarting. It's no change. If I explicitly clear all flags, okay. Let me try that then. We clear the reset flags and see what is the last issue. Oh no, I didn't upload it. Let's stop that. Download it. And debug again. Yeah, it's the same. Okay. Same. It's so weird. Pause. Now it's dead. It's always the same value. Okay. You don't get anything out of that. Okay, watchdog. Disable watchdog before we change that. Maybe we can change the capacitance. Wondering if that could be an issue. It's the stream? Yeah, most probably. The lights. And we close that. Okay, this is resetting. Let me change capacity. Okay, you know what? I use default capacitance. I'm wondering if there is an issue with, possible issue with that. Nope. What values do we have? Let's try 6p. If that changes anything. Nope. And what's the highest value? 20p. Yeah, I doubt that that has something to, anything to do with whatever's happening there. I might ask Charles community for that, the CH32 Fun community, if they must have experienced that as well. At least the people who are playing with that regularly, because this is not the first time I'm seeing that behavior. It was never able to fix that. It is weird. Let me switch the MCU here. So, how do I do this? Yeah. It's really horrific if the chips are just dying randomly when working with them. So I'm not sure if I will be, yeah, I mean, I can try to work with that, but I need to be sure that my code isn't causing that. Alright. I have no clue of the status of this MCU. It might be also like not working at all. Okay. Try to download that code. I'm not sure if I plugged it in correctly. Oops. Yeah, that's correct. But these two. Okay. Yeah, but why this weird behavior? It's always the same like amount of time that it is glitching. Okay, let me disable this. Don't think I have either. I don't know if this is even working. This board, because that was already reworked and I have no clue. Nah. Ooh. That isn't. Oh no, this isn't working. Yeah. I think today there is no way I can figure out what's wrong with that anymore. I could reflow it and give it a new chip and then test it again. But why it's dying, I have no clue whatsoever. This is so really weird. Might have been like an issue with power overload or whatever, but really usually that doesn't happen with those things. I mean, except for this chip. Same behavior. It's the same behavior with two different chips already. Mm. Mm. Okay, you know what? I will try to download the target file. So, level 0 object file. Copy path. That's the target file. Enable reset, enable watchdog, all is off. Program verify. Disable code protect. Nope, it's resetting. It's a hardware issue. Our code was working. Now I messed around with the code so much. So actually this one was working fine. So let me remove all that crap. Download it again. And plug that in. Oh. So I can just work with like 300 milliseconds of boot up, and then that's all. Huh? Why don't I see anything here? Oh yeah, okay. This thing is still not sending anything. Do we have the while loop? Yes. Okay. All right, so I destroyed it. It's not working. Huh? Now we get nothing or what? Or maybe I'm not connected to the correct, yeah, I'm not connected to the meso. Yeah, wait a second. Where is my meso and what is my mosey? This is that. That's the chip select. No, yeah. But I want not the chip select, I want this here. Okay. Okay, that looks completely random now. Oh yeah, wait. Didn't we have a counter or something? Oh yeah, wait, it's not sending anything. It's not entering the interrupt here. Packet counter. Okay, let's remove that part. Oh, this is so messed up. I should have checked in the code, at least temporarily, because I don't see it working anymore. Okay, let me check. 5.6. Oh, this is when we removed that part. No, that was stable after some time. Wait, not this. Oh, the interrupt flag wasn't cleared. Now it should be, yeah. It looks like it's jittering more often than the reset. It's more random. Nope, that doesn't change anything. Okay. It's dying. Okay, I think that's enough for today. It's very frustrating that we had to deal with hardware issues and it held us back from being excellent. I'm asking for if there is, oh wait, wrong chip. No. Yeah, unfortunately. Oh, I'm reading here V3 pin power configuration error. Must be connected to ground through blah blah capacitor. Miswiring collapses in the internal core voltage regulator causing continuous brownout reboots and communication failure. Okay, so current 6 pin delay, RC network problems. Yeah, that's not it. Nope. Stall. Requires stable. That is not it. Stray capacitance, TXD level during hardware reset. Wondering if my implementation on the actual, but I had also on the motherboard an issue with the with an broken chip. Okay. All right. Good night, everyone. Sorry about that. I couldn't do anything except like reflowing now, but yeah, I wouldn't do it right now. I have to prepare stuff. I will try to do it tomorrow and then see what happens. Yeah, sweet dreams as well. Good night, everyone. So sad. The day started so great and then that happened. I'm not sure why. It's already the third chip. Bye bye.